homework. Now again, this shouldn't take too long what we're going to do in class today, but I want to make sure we go over the homework. I want to make sure we review and that you're ready as much as possible to take your quiz today, which hopefully you figured out. Oh yeah, there's a quiz today. And then I'll give you as much time as possible to get started on your labs today too. So hopefully this shouldn't take too long. Alright, your homework problem was to only do on page, in that chapter review, I believe it was on page 91, was the problem number 2. It might have been on page 92. Yeah, this one was on page 92. So problem number 2, talking about calorimeters. So remember, what equation do we work with whenever working with a calorimeter specifically? Remember, it's the Q loss, or the heat lost of the metal will equal the heat gained by the water, but we don't use this version of it. Did I write with the bar? I always do that. But we don't use it this way. I'm going to draw a line so I don't forget to write there. I always forget what that top bar is. So, the heat lost by the metal equals the heat gained by the water. But we don't use it with this way. We substitute Q out. So, because of that, it's negative Cm delta T will equal positive Cm delta T. Or in a lot of cases, because the positive sign is understood, we just leave it off. Alright, so let's go ahead and let's solve this. Alright, so I'm going to shift the screen down a little bit because you don't need to see the PowerPoint. There's no PowerPoint today. Alright, so how do we solve for this? So it says a 92.2 gram sample of gold at 100 degrees Celsius is placed in 100 grams of water at 21 degrees Celsius. The final temperature of gold in water is 23.2 degrees Celsius. What's the specific heat of gold? Alright, so just plug in, what are you given? Alright, first off, this is the metal side, so let's plug in all of the things we know about our metal. Alright, it says it's gold, which is nice, but that doesn't tell us a whole lot to solve this for mathematically. Alright, but it says I'm starting off with 92.2 grams. So writing off to the side, yeah, you can still see this. So negative C, I don't know specific heat of gold, but that's what we're finding. So the mass is 92.2 grams. The change of temperature, remember how do I find change of temperature? It's final minus initial, so you get good habits of getting the correct sign. So the final temperature is 23.2. I'm going to leave off degrees of Celsius right now, but it started at, it says 100 degrees. So make sure you match up the proper variables again, because don't just see, oh, 21 degrees. Remember, that's the water. So the piece of metal started at 100 degrees. Wow, the final temperature was 23.2. So 23.2 minus 100, that is negative 76.8. So that's how you figure out the proper temperature change. So negative 76.8. I'm going to leave off degrees Celsius right now. All right. So this is for the metal side. Now for the water side of it. Now, what's the specific heat of water? Your book doesn't tell you, but because it knows you have it in the chart. So what is the specific heat of water? Again, you don't have to memorize it, but you probably will. 4.18 joules per grams degrees Celsius. How much water do I have? What's the mass? 100 grams. 100.0 grams technically. Oh, I wrote too far over. I'm sorry. And now remember, just ignore the bell. Sorry, I started earlier. So, what is the starting temperature of water? 21 degrees. So, it went from 21 to 23.2, so the temperature change for this one is 2.2 degrees. So, positive value, 2.2 degrees Celsius. I think you can still see that barely. Maybe. So 2.2 degrees Celsius. I'll slide it over just a little bit. Alright, so how do I solve for this? What do I do? Remember, I gotta get C by itself. So because of that, instead of multiplying, I divide. So this is an understood 1 over here because a negative 1 times a negative number will balance it out to get a positive. So it's understood negative 1, 92.2 grams with a negative 76.8. So that'll cancel out my negative sign, that'll cancel out my 92.2 grams, and that'll cancel out the negative 76.8. So the whole thing becomes 4.18 times 100 times 2.2 divided by negative 1 divided by 92.2 divided by 76.8. Because remember, you want to take the entire top, multiply all of it together, and then divide it by the entire bottom. So that's going to be, you want to type it in that way in your calculator. The answer comes out to, I'm gonna write it, I'll write it over here. Good, you can see the spot. Alright, so it comes out to 0.12986, and then I got tired of writing it at that point. So, looking over with my sig figs, I have 3 sig figs, 3 sig figs, 3 sig figs. Now remember, for the temperature changes, you want to look at the start, not at what you ended up with. So I started off with 21.0 degrees Celsius and 23.2 degrees Celsius. So all of those have 3 sig figs, except for the water one, except for the gold with 100.0, but that's 4 sig figs. Since it's multiplication and division, we go off the number, so 3 sig figs. So how do I make my answer 3 sig figs? Alright, 0.130. Now remember, why does this 0 count but not this 0? Right, because it's to the right of the last non-zero digit, and there is a decimal point. And then my units are joules per grams degrees Celsius. So that becomes my final answer for this problem. So hopefully you got it. Hopefully you did well on that problem. Hopefully it didn't stump you too much. If you still get stuck, be sure to ask me on Monday when you come back to go over this. That way I can help you out for it, because you need to know this for your test coming up and for any quizzes that occur. Alright, not today though, but just make sure you do know it. Alright, so let's go over and review for it. So you'll notice I wrote the pages on the board that you need to know. So pages 77 through 82 for your classwork. Go through and try to copy down as many bold terms and definitions or italicized phrases if you know what I've been talking about for the italicized phrases for the past couple of days. Go ahead and write some of those down as well. So about 5 to 10 minutes if you want to cram and study it as much as you can in about 5 to 10 minutes. Now don't spend too long, you gotta come back, because I'm gonna review with you as well. But try to go ahead and take about 5 to 10 minutes, copy out as many bold terms and definitions from those pages as you can, and try to see how many can you get through, just to help make sure that you know all the material. So go ahead and pause the video, and then work on that. And then unpause it after about 5 to 10 minutes. Alright, assuming that you're back now, let's go ahead and let's go over those bold terms and definitions. And also I'm gonna go over the italicized phrases that you need to know for today in particular. Alright, so what's the area of chemistry that deals with applying thermodynamic principles to energy changes in chemical reactions? Chemical thermodynamics. What is the study of the flow of energy? Thermodynamics. Make a note, there's chemical thermodynamics and then there's regular thermodynamics. Thermodynamics is just the study of the flow of energy. Chemical thermodynamics has to do with the area of chemistry that it deals with applying thermodynamic principles to chemical reactions. So just make sure that you know what they are. Alright, what is considered the ability to do work? Energy. What law says that energy is neither created nor destroyed? Law of conservation of energy, and then remember the first law of thermodynamics takes it and put it in a more exact wording for it. Alright, the different types of energy we've talked about. What is the energy associated with motion? Kinetic. What is the energy associated with the forces acting on an object? So is the energy associated with the position of an object relative to the force upon it? Potential energy. Alright, when thermodynamics, what is the portion of the universe we are studying or looking at? The system. What is everything else in the entire universe for all practical purposes? The rest of the room. Surroundings. Ignore the bell again. I started early. Alright, so make a note. System and surroundings. Alright, what is the symbol that first of all, what is the sum of all the possible forms of energy of all the ions, atoms, and molecules in a system? Right over here. Internal energy. Now remember, we use E to represent it. So make a note, E, internal energy. So make a note of that symbol. Alright, what do we call a value that is determined only by the state of the system, like climbing a mountain? Doesn't matter how you got there as long as you're there. That's the state function, so make a note for that. Alright, what is the symbol used for heat? Gotta know your symbols. Q, good job. What is heat? This is the transfer of energy between objects or a system. So remember, does heat always go from hot to cold objects or cold to hot objects? What direction does heat always flow? Right, from warmer objects to colder objects. Always goes from high to low, like gravity or like water. You can think of it that way. What is the symbol for work? W. So remember, E is internal energy, Q is heat, W is work. What is the symbol that's used to mean change? Delta, or it looks like a triangle. So either one works for that. What is the equation for the first law of thermodynamics? Delta E equals Q plus W. So make a note, that's the practical law of the law of conservation of energy, or the first law of thermodynamics. are gaining energy. Is that positive or negative? And your viewpoint, if you are the system. Positive. What if you're losing energy? Negative. What is the SI unit of energy and energy transfer? The joule. Alright, what is defined as the internal energy plus the product of pressure and volume? We talk about this when we're talking about gases specifically. Enthalpy. Good job. What's the symbol used for enthalpy? H. Now remember, if you're a solid or a liquid, is there any real significant difference between the change in internal energy and the change in enthalpy? No. If you're a solid or a liquid, because your pressure and volume isn't really changing, in most cases, the change of internal energy will equal the change in enthalpy. It's only with gases whenever you got to get more specific with that. Alright, so if you have a reaction that is endothermic, what does that mean? That means that it's absorbing energy as part of the reactant. We typically draw it as reactants plus heat, or plus Q, equals the products. What would be an example of an endothermic reaction? You could have said, like, if it's a state change going from like ice cubes melting, that's an endothermic process. Or you could have said, like, this instant cold packs, whenever you crack them and they get really, really cold because the reaction is occurring and they're absorbing the energy around them. Or you could have said, like, cooking an egg or cooking steak, the meat or your egg is changing because it's absorbing energy. So all of those are endothermic. Now typically, if you have an endothermic reaction, are the products typically colder than the reactants or hotter? Right, typically they're colder than it because they have absorbed that energy. And that's what I'm talking about in particular for the cold packs. They get really, really cold, noticeably colder, because you can tell that, oh, they are reacting, they are absorbing the energy from the air around them in order to cause this reaction to occur. What do you call, as a side note, if you have an endothermic reaction, what sign will the delta H have, or the enthalpy have, or internal energy, but what sign will it have if it's endothermic? Right, positive. So it'll either be positive delta H or delta E. But it's the idea that, okay, it's absorbing energy, so it's gaining energy, so it has a positive sign. Alright, if you're exothermic, what does that mean? It means the reaction is producing heat. So we draw it typically as reactants. As they're producing their products, they are making heat as well. So these, do they typically feel hotter or colder to you? Typically, their products feel hotter because they're giving off heat, and that's how when you put your hand up to it, you can notice heat's coming off of it. So, will the change in enthalpy or internal energy, will that be positive or negative if it's giving off heat? Right, negative, it's losing it. So, negative delta H or delta E. Either one is the idea. So remember, if it's a process like endothermic, it's absorbing heat or it's gaining it. So we give it a positive sign for its change of energy or change in enthalpy. If it's exothermic, it's losing heat. So because of that, it's producing it or giving it off. So we say it's a negative value for delta H, or negative value for the change in internal energy. Alright, what is the heat required to cause a unit rise in the temperature of a unit mass of a substance? So this, we can use this to identify an object. Specific heat, good job. What's the equation for specific, what letter first of all is given for specific heat? You gotta know your symbols. C, lowercase c specifically. What's the equation for, wrote it where the bar is, right off to the side, lowercase c. What's the equation for specific heat? I'm gonna write it over here. C equals Qm delta T. We can also take this in a different version to find Q. So I'm not going to take time to do that now though. Alright, what is a device that is used to measure heat flow, particularly chemical reactions? Calorimeter. So calorimeter, it looks like calorimeter, but calorimeter is how you're supposed to say it. Alright. So that is everything for your quiz. So if you realize you want to pause the video so we can go ahead and study really quick right before you take it, that's fine. But be sure to come back. Don't spend too long. But if you want to go ahead and study everything really fast one more time, that's okay. All right. If you're back, I'm assuming that means that you're ready to go ahead and take it. So clear your desk of everything. I'm going to clear the board. So sorry if you needed this. Copy down quickly. Pause your video and rewind. So So clear your desk of everything. You only need out just a blank piece of paper and a pen to take this in. You don't need your calculator, you don't need your book, you don't need a cell phone, so put all of that stuff away so that way it won't distract you, declutter your area. You only need your pen and a piece of paper. So if you realize you need to go get a piece of notebook paper, go get one really quick, then come right back. But don't watch this section until you're ready to actually take the quiz. Alright, so remember to write your name and the date at the top, so whenever I print off all the pictures later, I know whose is whose. So write your name and date at the top, and then label it 1 through 10. So 1 through 10 on the piece of paper, like how you normally do. Alright, so these first questions, you're going to just answer the questions. So just write down your answers on these first blanks. Alright, number 1, what is considered the ability to do work? What term means that? So what is considered the ability to do work? Number 2, what is a device for measuring heat flow? What is a device for measuring heat flow? What's that device called? Number 3, what is the heat required to cause a unit rise in the temperature of a unit mass of the substance? So what is the heat required to cause a unit rise in the temperature of a unit mass of the substance? Number 4, what is the SI unit of energy and energy transfer? What is the SI unit of energy and energy transfer? Number 5, what symbol or letter stands for work? So just write the letter or write the symbol. What is the symbol or letter that stands for work? What is the letter or symbol that stands for enthalpy? What is the letter or symbol that stands for enthalpy? And then what letter or symbol stands for change? So what letter or symbol stands for change? Alright, these last 3 are true and false. So you either just write true or you just write false. So you don't have to change it. But if the statement is true, just write true. If the statement is false, write false. So you have 50-50 shot of getting these right. Alright, number 8. The portion of the, in thermodynamics, the portion of the universe being studied is the system. True or false? In thermodynamics, the portion of the universe being studied is the system. Number 9. Potential energy is the energy associated with motion. True or false? Potential energy is the energy associated with motion. And then number 10, if a reaction is absorbing heat as a reactant, the reaction is exothermic. So if a reaction is absorbing heat as a reactant, the reaction is exothermic. True or false? Alright, if you need one of those questions repeated, just rewind a little bit and then go find the proper question again for it. But once you finish it entirely, go ahead and put it off to the side. Don't forget about it. Be sure to give it to your proctor, your mom or dad, whoever it is that's actually sending me photos. I want it today as best as you can. So send it to me as fast as you can. But you go ahead and put it off to the side. Just don't forget about it. Alright, now you can go ahead and take out your lab book. So we are working on Lab 10 today, or because you're going to start watching it. So Lab 10, you'll notice there's 2 parts for it, so you're going to start it today and finish it tomorrow. So read over it. Now you're going to have to think while you watch this lab. I'm not here to answer your question. Well, I mean, you could email me, but it's not like it is in class where I can pause the video and explain it. So you're going to have to pay really close attention as he's going through it, because he explains it and does a good job explaining it, but you want to make sure you're following along. If you look at the report sheet on page 57 in your lab, you'll notice that there's this giant summary table towards the middle of it. Well, not giant, it only has 3 blanks. Now, he does not go over the answers with you there. So, just make sure, though, that you're paying attention. You're going to have to think of, okay, what's happening, what's going on with the acid that he's reacting with it, what is it producing. He does go over it at the very end of the lab, but that's much later, and it'll mess up some of your answers if you're not doing it properly. So, you can find the information in the lab as he's doing it, as you pay attention. You can also find some of the answers in the lab manual in the procedure section. So if you get lost, follow along in your book and see, okay, what's happening in the procedure section. So that way you can tell, oh, okay, I see what's going on with it, and I can see what's happening for it. So between watching the lab and reading the lab, you can answer that table. So don't just get stuck and think, I don't know what to do. He'll help you out with it as he's going through it, but then he also kind of re-explains it at the end of the lab. But if you wait until the very end and fill out that table, you're gonna have some trouble. So that's probably the reason how come you want to pay really close attention. Read the lab manual if you get really stuck, and then also pay attention as he's going through it, because he does a good job showing it. But I'm not here to answer your questions, so you have to pay attention for it to make sure that you know what's happening. Alright, you can answer all the questions though on the front page. On the back page, you'll notice that there's another chart, so don't forget the back page. And you also have some questions. The only question you have to do is question number 1. So, circle number 1 or make sure you make a note. That's the only question you have to do. If you want to try 2, that's fine. But question number 1 is the only one you have to do. And you have to do that entire chart at the top of the page. So, make sure though that you answer at the front and back, both sections. So, the front page, page 57, and the back page, page 58, but you only have to do question 1 in that top portion. You don't have to do question number 2 down here. You can do just question 1 in that top section, not question 2. This is due on Monday, so be sure to bring it to school with you on Monday, because hopefully we're starting back then with in-classroom studies. So, the lab report sheet is due Monday. I'm not going to record a YouTube video tomorrow because you're just watching the lab and we've covered everything that you need to. But that is the only thing that you have for Monday. We've gone over some of the things to talk about for Monday, but I want to review and stuff as well for it. So this is your only homework for Monday. So bring in your lab report sheet. You can finish the whole lab today if you want to. If you want to go ahead and just watch the whole thing, just get it over with, that's fine. Just make sure you have this lab report sheet finished and it's due on Monday. I hope you have a great day.